All right, welcome back. So last time, we talked all about the internet's traffic cops. The routers and switches that figure out where our data needs to go and point it in the right direction.
But that leaves one huge question, right? We know the destination, but what are those digital roads actually made of? I mean, are we talking smooth, paved highways? Or maybe invisible airways? Or is it something else entirely? Come on, let's follow the data and see what kind of journey it really takes.
Okay, so our first stop on this little tour of the digital city is going to be the most reliable road in the neighborhood. Let's talk about the good old Ethernet cable.
The best way to think about Ethernet is to picture it as a perfectly paved, freshly painted asphalt road. It's the main street in your personal digital city, what we tech folks call a local area network, or LAN. It's a direct physical connection. There's no guesswork, no getting lost. It's just built for rock-solid stability.
But of course, not all asphalt is created equal. A standard Cat5e cable, that's kind of like your basic city street. It's great for everyday traffic, and it'll get you speeds up to 1 gigabit per second. But if you upgrade to Cat 6 or 6A, well, now you're talking about a multi-lane superhighway. This stuff is way faster, up to 10 gigs, and it's built tougher, so it's much better at ignoring road noise, or what we'd call electrical interference. So when do you actually want to be on this paved road? Honestly, it's the best possible choice for any device that doesn't move and needs every last drop of speed and reliability. I'm talking your desktop computer for sure. Your gaming console? Absolutely. Every millisecond counts. Media servers, smart TVs. If it stays put, plug it in.
But let's be real, nobody wants to be tied down with a physical cable all the time. We want freedom, we want to move around, and for that, we have to take to the skies.
And this brings us to the invisible air transport system of our digital city, Wi-Fi. Instead of a wire, Wi-Fi uses radio waves to just beam data packets right through the air. And its number one advantage is just pure, beautiful convenience. But, flying has its own set of challenges. The pros, they're obvious. Total freedom to wander around. The cons, though, they're kind of like dealing with bad weather and air traffic. Stormy weather is what happens when things get in the way, like walls or your microwave or even your neighbor's Wi-Fi network. And air traffic, well, that's because the air is a shared space. The more devices you have all trying to talk at once, the more credit it gets and everything slows down. So how do we manage all that traffic? Well, this is where our air traffic control gets a major upgrade. Wi-Fi 5 was pretty good, but Wi-Fi 6 is a whole other level. It's not just about being faster, it's about being smarter. It is fantastic at managing all that heavy air traffic, talking to tons of devices at the same time super efficiently. In a modern smart home, with phones and laptops and speakers and lights all screaming for attention, that intelligence is everything. Okay, so we've got our local roads and our local airways covered. But how do we connect entire cities, entire continents? For that, we need something on a completely different scale. We need a hyperloop. Yeah, just look at that number. Nearly 300,000 kilometers per second. How is that even possible? Well, it's because fiber optics don't push electricity through copper. They send data using pulses of light through pure glass. Your data is literally traveling at the speed of light. This is the top of the mountain, and the way it works is almost magical. First, your data, your ones and zeros, gets converted into little flashes of light. Then, these light pulses shoot down these impossibly thin strands of glass. And when they get to where they're going, they're just converted right back into data. It's so simple, so elegant, and unbelievably powerful. And using light gives fiber 3 incredible superpowers. 1, just mind-blowing speed and bandwidth. 2, it can travel insane distances, like across the bottom of the ocean, and the signal barely weakens at all. And 3, and this is a big one, since it's light, not electricity, it is completely immune to the kind of interference that messes with Ethernet and Wi-Fi. This is why fiber optic cable is the backbone of the entire global internet. So after our big tour of the digital city's infrastructure, we're back where we started with a really simple question. Which path is the right one for you? So let's just lay it all out. If you need that unwavering, rock-solid stability for something that doesn't move, you take the Ethernet asphalt road.
If you value being able to walk around more than anything, you take to the Wi-Fi airways. And if you need the absolute peak of performance, raw speed that nothing else can even touch, then the fiber optic Hyperloop is the only way to go. The real secret, though, isn't picking just one. It's using a smart mix of all three to get the best of all worlds.
So now we get it. We understand these incredible digital roads our data travels on every single day. But it does raise one last really important question. Are these public highways actually secure? I mean, can anyone just peek at the data we're sending? And what if we want to build our own private protected tunnel just for us? We're going to dive into exactly that next time.